through today, and the goal is for us to start by getting our notes done. If that gets done first, that allows us to spend more time on stuff that's going to get you used to how to answer an AP question and make sure that your notation is on solid footing. Okay? So, what I need everyone to do is, let's start off with your notes. We left off on page 16. It says day 8 at the top. Somebody had asked previously, when is our first exam? Now, the way to find out, you track on the calendar in the beginning of your note packet. Just trace the days out. That's when it is. I'm terrible at planning, especially with this schedule, because it cycles 3 out of 4. I'm like, is that Monday, Tuesday, whatever? You can fill in the days right now. You know when your test is going to be, whatever day it is. Maybe at the end we can have somebody let us know. But make sure, please, that everyone right now has gone through and signed into your calculator. If you haven't yet, you need to. We need all of you to make sure that you're logged in, because there's times where we're going to be pushing information out to you, and there'll be times when I need to pull information and screenshot what your individual graphs are and send large data sets out to you, etc. So make sure, if you haven't already, that you go through and log in. Now, we left off before talking about continuity. Hands up, please, if you can tell me what the holy trinity of continuity is going to look like. We got 1, 2, 3 of us who can tell me. 4. Davey, what do you want to say?
The left and the right come to the same point. One of them.
Well, that's 2 things. He talked about a left-hand limit and a right-hand limit. What do you know about the left-hand limit, the right-hand limit, and the function value? They all have to be the same. That's what you need to show in order to prove it. Now, a function is continuous on an open interval if it's continuous at every point in the interval. A continuous function is continuous at every point of its domain. It doesn't need to be continuous over every x value in order for it to be continuous. Take a look at this function here. If you were to use this, remember that your radicand needs to be greater than 0. Hands up, please, if you can tell me what the domain of this given function is going to be. Don't go to the calculator. What is the domain of that f of x going to be? Steve, what do you think? Interval notation. I'll tell you right now, one thing that Americans are pretty much 50-50 split on is who they're voting for president. The other thing that's even more controversial is whether or not you can take the square root of 0. It sparks debate. People thought, well, can I take the square root of 0?
Yes.
You're asking yourself what times itself gives you a 0? 0. Now, if that was in the denominator of a fraction, you would not be able to include it, but 0 is in the domain. 0 is in the range, so we have to include what causes the 0 in the domain. Now, this domain is not continuous, meaning not every x value gives you an output. Is this function continuous over its domain?
Yeah.
Yes. There's no value over its domain such that we'd have to take our pencil off of the paper, there's no holes in the graph, etc. Now, this is 1. We keep emphasizing this. Sometimes it's, well, and because when you get your first test, again, you're going to hit the wall for a lot of you. Because some of you are geniuses in your own mind, but not on paper. Let's be clear. The notation matters. You need to make sure that there's a limit in front as each step as we go until you take your direct substitution. When we talk about using correct calculus notation, calculus methods, justifying your answers, etc., it is at this point we're talking about using limits. Don't be a lazy Larry. Put the limit in front. I don't want you to go through and know 70 or 80% of the material, and your notation is going to bump you down to a 50 or a 60, and it happens. There's 40 points on the test. If you miss one or two of them for notation, that means you're already starting out 10% behind. And that's just a casual overlook. Now, this is going to be our first function, f of x. Find the limit as x approaches 6 of that f of x. Be sure to go through and use the correct. Now, which piece will I be using if I'm taking and evaluating out the limit of that function? Notice it's a piecewise function. It's defined one place when x isn't 6, and another way when it is 6. Which piece would I have to go through and use in order to evaluate out what my limit is? We've got one person, two. What do you want to say?
3 kids, 2.
I'd say no on that. Does anybody know why we would not be using that piece?
Because when x approaches 6, you're using values that aren't equal to 6.
Yeah, you're approaching the 6, so you don't really, does what it's doing at 6 impact the limit value? No. So, we're going to need to take our limit as x approaches 6 to evaluate out the limit. I would need to use that top piece. Now, looking at what's there, Catherine, what would you do to go forward with simplifying out this limit? Factor the numerator, and what's the numerator going to factor to?
Minus x and x plus 1.
Terrific. All over. Now, when you do that, at this point, remember nothing cancels, things reduce. Those reduce down to a 1. So again, now at this point, there's some of you who will say, well, can't I just go right to the answer? Yes, that's fine. How would I get what my limit value is? Evan, what do you say? And what do you get? So I went through and doing mine to make sure that you're actually close to as good of a mark as you can get. I put down the limit of that expression. Now, once I plug that value in and get an answer by direct substitution, I can go through and stop writing the limit in front. Some people keep writing the limit forever. That's just as wrong for the other reason. Some people don't write it, and some people can't stop writing it. Okay? Now, questions on that? So we know, as we converge on this graph, from the left and the right, what's the function value going to, what's the limit value going to be? 7. So what does it look like I'm going to get as my output value as I approach 6? 7. Does it matter whether I actually get that value? Will that affect the limit? No. The limit could be at 46 for all we know. The second piece, find a value such that it is continuous. Now, in order for this function to be continuous, what criteria does it need to meet? We've got one person. We literally just said this a minute ago. In order for this function to be continuous, what criteria does this need to meet? Hannah? Now, when you do that, I have my limit from the left and the right at equals 7. What else does it need to do? The function value at what? Has to equal, there you go. So make sure that that's down someplace on your paper. Now, how can I go about getting an answer from there? Take a minute, look at what you've got, and hands up please when you can tell me what we would do. How I could go about setting this up. I need the function value to plug that hole or to equal a value. Who can tell me what we would do? Really? Really? what's the limit, going to be equal to? Phil, what do you say? 7. And in order for this to equal, what piece of this piecewise function do I use when the x is 6? Oh, wait a minute. Oh, you can yell at me all you want. I think I made a mistake here. I don't know if I corrected it afterwards. What error do I have down on my paper right now? I don't have the right variable. Go through and solve for what that variable is going to be. Now, what value do we get, Jake? What did you say it was? Mm-hmm. Now, look at that. Questions on that? This is an AP calculus question, run of the mill. This is your everyday question. You've got to understand the concept, and we can't afford algebra errors. Take a look at the next one. I'm going to say right now, I will give you 3 minutes, and you all should be able to answer this question on your own without a calculator entirely. Ask what criteria you need to meet. Delve into the question. Ask yourselves, am I meeting the definitions that we've talked about? Am I showing it adequately? Don't go to the calculator because you don't need it. Megan, on this question, what do you need to do to show whether or not it's continuous at 5? Hang on, what did you say? Okay, so we're going to have to at some point factor down the numerator, and you're right. But if I needed to show continuity, what 3 things do I have to show continuity? Do you recall? Who recalls what the 3 things for continuity that we need to show are going to be? David, what would you say?
Left hand, the right hand, and the function letter.
Okay, so we need to show, in order to show that this is continuous. Now, if you're showing it's continuous at 5, that means we need to show that the left-hand limit at 5, the right-hand limit at 5, and the function value at 5 are all equal to each other. So there's 3 pieces. Now technically that's 2 there, because some people will say, well, the full function, or sorry, we need to evaluate out the limit at 5 from the left and the right. It's the same thing. Those 2 individuals come to make up the whole. So I'm going to evaluate out a limit as x approaches 5 from the left, from the right, and the function value at 5. So, Noah, which one do you want to go through and list out first? Do you want to do the limit from the left, the limit from the right, or the function value at 5? See, so easy. You pick the easiest one. What is f of 5 going to equal? 6. Okay, so we've got that down. Not too bad, right? Jack, which one do you want to do? Do you want to do the limit from the left-hand side, or the negative side, or the limit from the right-hand side, which is the positive side? Okay? So if you want to go at it from the right-hand side, that's this one here. Which piece would you go through and use? So I'd write out what? Of? Now, can you evaluate that by direct sub? What would you get? Thomas. Abby, how's your day going so far? Is this class the highlight of your day? Now, you're going to be doing the limit from the left-hand side of the function. So what would you go through and write out for the limit from the left? Okay?
Use it, the limit from x minus 5, conjugate times 5 is 1 over.
Don't forget the negative sign that's there. I know it's probably on your paper.
And then I use factor out x minus 5.
Oh, I'm sorry. I think we did that here. I'm sorry. And you already jumped right to that, and that's terrific. So now what am I left with? The limit as x approaches 5 from the left-hand side of what?
Out of x.
And what's that going to leave you with? So now, you're not done. Some of you are so ready to be done. You still need to summarize what you just said. Determine if it's continuous. Be sure to show all of your work. Well, Josh, is this continuous?
Yes.
Why?
It's the function value from the left, or the limit from the left and the right, and the function value is equal.
So put that in a sentence. And I love it. You're not too good for it. You absolutely aren't at all. Give me a summary sentence. Since the function value at 5 equals the right-hand limit at 5 equals the left-hand limit, then it's continuous at 5. You showed that that trinity was true, so go through and list it out. Questions on that? I'm hoping that you're getting used to it. The question level and rigor of every question is substantially different. Take a look, please, at the next one. Algebraic combinations of continuous functions are also continuous. Now, look at this g of x. There's multiple ways that we could get the g of x. So what I'd ask us to go through and do is this. Here's my left-hand side of it, and here's my right-hand side. Let's view it in 2 pieces. Is the sine of x continuous? Hannah 1, what do you say? Okay, so the sine of x is continuous everywhere. It's always, by the way, between what 2 values?
Negative 1 and 1.
Negative 1 and 1. Let's look at the other part of that. Jason, is x squared times e to the x, is that continuous everywhere, or are there ever domain issues with it? It's going to be, because you can't plug in an x and get something incorrect out. So therefore, what have we just shown? You've just shown that in its entirety is continuous because it's never not continuous. Now let's take a look at the f of x. There's two functions there really that are going through and making this up. The two functions, the first one up is the sine of x, and Kanji, is that continuous? Now the next one that we're going to look at is, and I don't remember how I wrote it, but is going to be 1 over x to the third. Is that going to be continuous everywhere? Well, it depends on how we view it, because I guess we're going to have some issue. Mike, what would you go through and say? Let's ask this, Mike. Is x to the third continuous everywhere?
Yes.
Okay. Is 1 over x to the third continuous everywhere? When is 1 over x to the third not continuous? So that sort of settles that. I didn't remember how I had listed it out. X cubed is continuous, but x cubed equals 0 when x is equal to 0. So we have to throw that out of our domain. So our second answer, when is f of x continuous? Over what intervals? Molly, what would you say?
3 to 0 and 0 to plus.
That's terrific. It's continuous everywhere but 0. She gave what the answer was in interval notation, which is terrific. Now, you need to remember, too, that view these things as compositions or nested functions. And when we talk about nested functions, that's one function inserted into another function. You have to be on the lookout for negative radicands. You have to look at it in terms of one function plugged into another. Now, and this is going to set you up so well for a process called the chain rule that we'll work with later. Looking at this, I see f of x is the product of two other functions. How did I get here? Well, I put this radicand into this box. So I'm going to start off and I'm going to say my h of x is this. Now, is that continuous everywhere, or do we have domain restrictions? Think about the cube root of a number. What's the domain of that going to be? We'll probably say victimize you all. Sierra? No what? It's not what? There's no restrictions on it. So what's its domain? Okay, so that means it's continuous everywhere because you can take the cube root of that. And the inside function, looking at that, what function did you plug into it to get out what f of x is? Josh? What function did we plug into this function to get this one?
The g of x?
No? Well, who can tell me what the g of x would be? Is that continuous? Pardon? That's a quadratic. That's going to be continuous forever. Now, the f comes from taking the g and inserting it into the h. So, what do we know about the domain of the f? It's continuous everywhere because both of those are continuous. Now, we have to be on the lookout for when we're going to be having some issues. We have to look out for negative radicands with even indexed roots. So the second root, you can't take the square root of a negative. Fourth root, sixth root, and so on. In this case, remember, we're saying that the the g of x goes into the h to make the f. So this function here goes into the h to get this function here. Who can tell me what the h of x would be defined as in this example? Fourth root. The fourth root of x. Now, is that continuous? Fourth root of x isn't continuous? Everywhere besides the negatives, can you take the fourth root of 0?
Yes.
Yeah, you can't. 0 to positive infinity. All values of x greater than or equal to 0. Now let's look at our inside function. And Sam, what would the g of x be if the g goes into the h to get the x? And what's the domain on that? So it's continuous everywhere. What would our domain of the f of x then be? Adam, what do you think?
0 to positive infinity.
So our domain is 0 to positive infinity, and it's continuous along that interval. There's no holes, no jumps, no nothing. Questions on that? Now, let's do this. Let's please have out on your desk the continuity sheet. Now, what we're going to do is this. I'm going to give you, yes.
For the last one,
Uh-huh.
so the function at 0 though, wouldn't you get negative 6 in the fourth root?
What did I say? Hang on.
Wouldn't it be where the inside function is equal to 0 to infinity?
Well, you're saying, so this is continuous from 0 going on, continuous. Oh, we would need to find when this, hang on. I see what you're saying. I don't think that I have this down wrong then. I have this one down wrong. It's going to have, yeah, because it's dependent on this here. So we have to set this to be greater than 0. So I'll modify that. I'm sorry, I didn't realize that this example caused that to happen. I thought I put something in there that it wouldn't ever dip below it. Maybe it should have been a +6. I'm sorry. You're correct. Thank you. Take a look right now, please, on the continuity sheet that we have. And what we're going to do is this. I'm going to give you about until 5 after. Okay? Take a look at this sheet. You have until 5 after. You should at least be able to get the question number 1, the front done. Focus on that. Make sure, please, that you have appropriate notation, etc. But go through right now and make sure that that 1 is done from the front. Go through. If this was in front of you on a test or a quiz, treat it the same. How much would you give? Are you answering the questions that are asked? be able to fight the urge. Don't use the calculators, please. Start off, please, for 1A. Let's examine, state the values that this is not continuous. So, John, what would you do in order to answer out 1A?
Find the value which the denominator, which would cause the denominator to be 0.
And how would you go about doing that?
Just write x equals 0.
No? You know x equals 0 is going to be one of them. Something even interesting. What do you want to say?
And you said it equal to 0.
What's the if? First
The
of all.
denominator.
Set the denominator to be equal to 0, okay? Now, I'm going to say this tentatively. You took too narrow of a scope. You said set the denominator equal 0. That is true. But what I want us to see bigger picture is, let's factor the expression as a whole. Okay? So if you factor, did you factor down the denominator? Okay, first thing you can do is take an x out. So this would be 2x cubed. Oh, boy, kill me. I'll take the x out and I don't change it. Okay. So this would be x times 2x squared plus 7x plus 3. And then up top in the numerator you have an x squared plus 5x plus 6. I look at that and I go, we can go further. We're better than leaving this as is. So what's the numerator going to factor down to? And what's your denominator going to factor to?
You still have the x, right?
Mhm. Okay. Now, something terrific is going to happen here.
X plus 3 and then numerator and denominator will reduce.
So, I know that this is not continuous. Let's do this first. I'm going to group all of this together, shrink it down to the side. So, we're going to now state a couple of things that we know are fact. We know that this is not continuous at x equals 0. What would there be at x equals 0? What type of discontinuity are we going to have? Think about that. What type of discontinuity will we have at x is equal to 0? I got 1, 2, 3, 4 of us. Think about what that graph is going to look like You know that you can't get an answer by plugging in a 0. There's a vertical asymptote there. So that's the first one. It's not continuous at 0. Who can give me another value it's not continuous at? What type of discontinuity do I have at x equals -3? We've got 3 of us who are away. 4, 5. We're getting there. Sierra, what do you want to say? No? A hole in the graph. And we know we're not going to get one at x is equal to -1/2. What are we going to have at x equals -1/2? Give more. We always try to give more when we're having a class discussion about it, because we want you to get used to why things behave the way they do. Questions on that? Next one up is B, evaluate out the limit with appropriate calculus justification. So if I'm asking you to do out B, Cameron, what would you do from here? What am I writing? The limit as x approaches -3. Okay? So what am I going to replace the f of x with? Now, keep going. So I'm going to write out the limit as x approaches -3 of what? Can you evaluate out your limit by direct sub now? What do you get? So -3 times 2 times -3 is +1. Now, the work that you did when you're griping and saying, this crotchety old bag is making me list out too much stuff, it pays dividends going down the road. Not only are you showing you actually understand what's going on, but shockingly, some of the questions on it state the equations of the vertical asymptotes. So, Steve, what are the equations of the vertical asymptotes?
X equals -1/2
X is equal to 0 and x is equal to, is it positive, a half, or negative?
Negative.
-1/2, all right. By the way, when we list out our fractions, can we list them out, please, as something over something? Some of you do like a sidewinder fractions. Next one up, discuss any horizontal asymptotes. When you see horizontal asymptotes, Catherine, what is that asking you to look at?
The thing, with the highest degree.
More than that. What do we have to put in front of those? What's that? You're looking at end behavior. So, horizontal asymptotes means you are talking to me about a limit as we go out to infinity, positive and negative, of the function. That's what we're talking about. So, let's start off, and I'm going to say the limit as x approaches. Big decision here. Evan, do you want to do positive infinity or negative infinity? Terrific. Let's look at what happens as we go out to positive infinity. Oh, now, what was the original? Oh, you're gonna hate me for that. Let's see. I can do something else. All right, so we're gonna take the limit as this goes out to positive infinity. Well, this really is asking me to evaluate the limit as x goes out to positive infinity. What's driving the behavior of the numerator? Hannah, too, what do you say? The x squared is. What's driving the behavior in the denominator? What is that going to as you go out to positive infinity? Therefore, we can now conclude that we have a horizontal asymptote. And what's the equation of that horizontal asymptote going to be? Valentina, what do you say? What's that? Close. Y. Now, you've got to test the other side. The calc people love watching you and thinking that the only limit that could possibly exist is going out to the right. We're going to take the limit as x goes out to negative infinity, and it's going to look shockingly like what you've done before because it's pretty much the same thing with a different infinity. What's driving this behavior, Jake, is we go out to the left-hand side. What's that going to equal? 0. Now, keep in mind, this would be positive, this would be negative, so it's a small number over some huge negative number. That's still going to be 0, though. So we would have another horizontal asymptote of y equals 0. You got the same thing twice. Problems on that? Now, for 2a, actually let's do this. Save that for just a second, because I'm going to discuss briefly. Go over, please, to your limits worksheet B. Because, again, I don't want to have to give myself a mild aneurysm looking at your work or lack thereof. Some of you, by the way, even just the penmanship looks as though you were writing this on a plane while it was landing, or perhaps you were in a bar fight on a Friday night and said, you know what, while you're punching me for just a minute, do you mind if I do my calculus worksheet B right now? That's what it looks like. Now, if I'm taking and evaluating out this limit, the first thing I'm going to do is I look at this, well, I guess we'll say this, determine the limit as we go out. So I'm going to say the limit as x approaches 0 of this. Now, I look at that, what do you see that you want to handle right away? If I'm evaluating out the limit as x goes to 0, I know I can't plug in a 0. What do you want to do to handle this? Let's see. Dave, what do you say? Okay, when you factor out an x from the numerator, what are you left with?
X times the quantity of x squared minus 1.
And how about down in the denominator?
X times quantity x squared minus 1.
All right, so I see that. Next step, limit as x goes out to 0. This would be x times the quantity x plus 1 and x minus 1 all over x times the quantity of x plus 2 and the quantity x minus 2. Now, we're going to look for reductions that can go through and happen. These are now gone. You can tell me, please, what this limit would be. What's the value of this limit going to be? 4 of us? Noah, what do you say? What are the zeros of the function? How do you determine what the zeros of the function are? Jack, do you know?
2 and negative 2.
No. There are vertical asymptotes. At x is equal to negative 2 and at x is equal to positive 2. Who can tell me where the zeros of the function are the function going to occur? That's when the function value or the output is 0. We've got 2 people. Abby, what do you think?
At 0.
Close. Why isn't there a 0 at 0. Think about it. Do you know why? Okay, 9. That's why we're exclusionary of the 0. You don't let it play. There's a hole there. Write an equation for each vertical and horizontal asymptote with appropriate calculus methods. Now, one of these is going to be super easy to do. I'll give you a hint because in my exuberance to answer out as much as possible, I already answered one of those. Which one of these, Hannah 1, do you think would be the easier one to answer? Okay, where are they? How did you know that? What makes them? Why do you know that those are where the vertical asymptotes are? Who can tell me what causes a vertical asymptote? They cause your denominator to equal 0. Now the next thing we're going to look at is horizontal asymptotes. So looking at horizontal asymptotes, what do we need to show? Who can tell me what we need to show to answer out for horizontal asymptotes? There you go. So we're going to take a limit as x goes out to positive infinity of, and I'm sorry, was it x cubed? Which one was in the numerator? Minus x?
Yep.
And then the denominator was the cube minus 4x? Okay. What's driving that behavior, John, in the numerator?
X cubed.
And in the denominator?
X cubed.
All right, so I've got the limit as x goes out to positive infinity of x cubed over x cubed. What's that going to give me?
4.
Over here, now I'm going to test the other direction. The limit as x goes out to negative infinity of x cubed minus x, plus 4x. What's driving the numerator, Jason? What's that going to give you? So what's your horizontal asymptote going to be? Conchi, what do you say? Perfect. That's great. Describe the symmetry of the graph. Do we remember even and odd functions? Yes or no? Okay, we got some yeses and some no. So what we're going to do, I think I have this down. Please. No. Shoot. All right, so your job is to plug in a negative x. If you get the same as the original, it's even. If you get the negation of the original, it's odd. And if it's neither, it's neither. Let's start off in even y-axis symmetry. This is origin symmetry. Sorry. Forgot to put that down. So I'm going to take f of negative x, which would be negative x cubed minus 4 times negative x. Oh, it's just minus negative x. Oh, makes me so angry. Yeah. Can you go to Mr. Grozo's office at the end of the block? Okay. Thank you. There's police officers ready to arrest them? Oh, that sounds like something that they found in their car. Make a She's saying take the plea deal when they offer. Okay, thank you. Bye-bye. Now, so the numerator I have down wrong, that 4 is in the bottom, is that right? This is just minus x up top, minus negative x. And then this is minus 4 times negative x. Let's simplify this down. What's negative x to the third going to give me? The negative x cubed. Minus negative x is plus x. Over here I've got minus x cubed, and then this would be plus 4x. Compare this to the original. Is this the same as the original? Yes or no? No. Is it the original negated everywhere? Yes or no? Okay, so what does that mean? We know that this function is odd, and that means that it has what, Cam? Now, here's another one too. I love this. Somebody came in and asked, and we got to this point. This is such a question that tests your ability for the AP. When we do this out, right, we're going to rationalize. So I've got the limit as x approaches b. I've got b minus x all over root x minus b, root b. They did all of the algebra so terrific. They multiplied by root x plus root b. Got everything to simplify down, because this ends up being the limit as x approaches b of, now when you did this, what did it simplify to? It was the negation of
That root x plus root b.
okay, now can we take our limit by direct substitution here?
Yeah.
Sure. What are you supposed to replace the x with? B. So this would be the negation of root b plus root b. What is that going to give you? Negative 2 roots of b. Okay? Now, your homework is as follows. You picked up worksheet C. That's to get done. We're actually going to take, thank you. We're going to take a minute or two, do this for homework, right here. Worksheet C. What does it say on our checklist that's in front of the packet? What day does it say that's due? Okay. So, get that done. Get your Math Excel homework done. And I will say this. You've got one more day to tighten up and give me masterpieces on worksheet D. Capiche? Have a great rest of your... Do we like the pumpkin smell or should we ditch it? Okay.
Josh, yeah.
I think
Yep.